Right, good time of day, everyone, and welcome to a new MLIR open meeting. Today, River is going to present a new feature in MLIR, the language server and the integration in IDE like Visual Studio. River, you're on.
Hello, everyone. I'm River. I work at Google, and it's way earlier than I would normally be awake, so we'll see how this goes. Today, I'm going to talk about something kind of been doing on and off for a little while. No, I guess not too long, which is providing a language server for MLIR, and it's basically because I want IDE features when I'm working with .mlir files. So yeah, we're going to go over some of that. Also, this talk is more demo-y than slide-heavy, and slides have pictures. So feel free to stop me during the middle of it and ask questions. I don't really mind. I don't think we'll take the whole time, to be honest, but we'll see. So before I guess, detail how we're doing it or what the language server is, I should probably give some context on the background of what mechanisms we're using to provide a language server, because I think that's important. So basically, we're going to be implementing a server as defined by the language server protocol. But before I go into that one, I think it's probably really important to kind of understand how language tooling used to work in the old ways. The olden days, which is kind of more and more olden as time progresses. But this is actually still kind of relevant today. Also, these slides are semi-stolen from clangd talks, but I think those slides are actually pretty good, so that's why you see them right now. So if you think about language tooling and how it used to work and kind of still does to some extent, you kind of have this matrix of programming languages on one axis and editors on another axis. And if you've seen any kind of LLVM or MLIR talk, you can probably get the gist of where this is going when you have languages on one side and something that's being targeted on another side. So if we kind of dive a little bit into one of these axes, in the old days, a lot of times what happens is that the amount of support and features and just all-around goodness of the language plugin actually varies quite a bit. So we'll see this with Vim, where the support for one language is much stronger for another language. And this is because a lot of times these plugins don't necessarily share the same code, especially if they're not natively provided by the editor developers themselves. So that gets very problematic if you feel very passionate about a specific editor, like a lot of Vim users, and you can't really use it for a language that you want to try out because the support just isn't there. And if we different axis in this grid, C++, for example, even though C++ is still C++, there's many different plugins for different editors, and they don't really share that much code either. I chose C++ on this axis because I think it's the more interesting one, because if you actually look at it, they do kind of share code, because most C++ plugins don't really write their own C++ parser, because that's a lot of work. So they usually use something like libclang. But even using libclang oftentimes doesn't really have a lot of the tooling that you would want for an IDE. It has a lot of support for kind of interfacing with the AST from C++, but not necessarily like collecting all of the references or building an index to provide cross-references and things like that. So along this axis, there's a lot of code that's still not being shared. That's often very, very specific to whatever editor that you're in. So for example, VS Code, you might have to write TypeScript to kind of connect the language parts to what you're doing in the UI. So if we kind of compare this to the compiler landscape, there's a lot of code written that was not shared. which is very problematic. Because if we take the analogy of your favorite editor, by the way, a lot of people really only invest in tooling for the editors they care about, because if you're not using it, then you're not necessarily compelled to support those use cases. That's kind of where the language server protocol came in. Is Microsoft, along with technically a few partner companies, developed this protocol to kind of solve that issue. And essentially what they do is create a divide between the UI side with the language clients, and these are kind of your editors that you're interacting with as a user, and the language servers that are interacting with the very specific programming languages. So this is very useful because now each side of this spectrum could focus only on the things that they care about. So if you're a developer on a language client, such as VS Code, you don't necessarily have to worry about, okay, how am I going to connect this to C++? How am I going to connect this to Rust? You can really focus on making the editor experience for the language server protocol, which is this shared interface. You can make the user experience for that really, really great. And then that's immediately available to any of the servers that implement the protocol. And the same is true for language servers themselves. So if you want to expose your language server in the olden times, you might have to worry, okay, how am I going to show this in the UI? How am I going to make this consistent with maybe other plugins? But with the protocol, you don't have to care about any of that. You can just focus exactly on your language to provide diagnostics and things like that in a very, very condensed form, and then just send that to the client and let them deal with all of the user experience parts. So it created a very, very nice separation of concerns that makes adding support for new languages or even new editors extremely simple. And I think this is something that is very important to have as context, especially for MLIR. But I think this, like, writing language servers is also something that's very, very interesting, even outside of the MLIR ecosystem. I've written several of them myself, and I think it's a very important background to have. So if we're looking at the language servers here on the right-hand side, hopefully at least one of them is familiar, which is clangd, because it's also an LLVM project. But there's also this Go please for Go and RLC for Rust. And to refocus the presentation now, kind of what we want to do is just add one of those for MLIR, so that we can take advantage of all of the UI features that everyone else in programming languages is. So that's kind of going to be the focus now, is the MLIR part of us providing our own language server to get these IDE features. And I think it's important for us to ask why we're even doing this in the first place, because, I don't know, I feel like whenever someone does something, there's always a why are you doing this mixed in there. And my first response is always, well, I believe MLIR is a programming language, and I don't think you can really convince me otherwise of that. I type it in my IDE, I compile it most of the time, and I interact with it as I would C++ a lot of times. Maybe it's not as amazing, I can't define classes, but it looks like a programming language if you squint hard enough. But more pragmatically, from a user's perspective of actually interacting with the IR, a lot of the times, the justification for me is, if you have ever wondered as a user yourself, okay, I'm looking at this SSA value, what is the type of it? I don't know what the type is. And I think this one is actually more important for us, because MLIR has this amazing quote-unquote feature, which is you can define your own custom assembly format. And we try to be pragmatic, I think, about custom formats, but not everyone follows the same style. So if you go from one project to another, it's happened to me before, I can look at an operation and its custom form, and I'll have no idea what anything means to be able to glean information from it. But I don't know what the type of this thing is. So you either have to guess or kind of feed it through opt. And the same kind of applies for finding where something is defined. So yeah, if you have a multi-thousand line snippet and you're like, where is this single SSA value defined? The best thing I have right now is Control F and then kind of hope I find the one version of %5 that is the one that defines my thing. And then the last thing on this list, I mean, there's many other things, obviously, but the last thing I have on this list is the generic form. And I kind of touched on this earlier, which is there's so many ways to write a custom form. And sometimes I just want to know what the raw thing is, like what attributes you have, etc. And a lot of that's not really possible unless you have a language server. And for me, they're really important features as a developer. So I figured I would just dive into the demo early on, because I feel like that's probably the most interesting part of the talk, at least from a user perspective. So let's see. Yeah. Is the font big enough to see? I'm just going to say yes, probably. OK. So my laptop screen has a super huge resolution, so can't actually scale VS Code that well. But if we're going to go over some of the features, I think the easiest one to start out with is what you'll see the most as soon as I start typing. And that's also one of my favorites, is the fact that diagnostics pop up in the editor as you're typing. So it's already complaining at me and yelling about something. Yeah. So this is nice for me from several reasons. The first of all, it feels like I'm in a programming language, which is nice. It gives me that nice warm feeling when the compiler gives me the red twiggly line. But also from a user's perspective, one thing that I've found really nice about this is that as I'm writing my verification test cases and kind of the parser ones as well, it's really nice to have my editor show me exactly what error that I'm going to be expecting when I run opt, without me actually needing to run opt to check to see, OK, I actually got the error line correctly and that stuff. So that's nice for me. So we can get rid of that squiggly line. Actually, I'll just keep it. But kind of along those same lines, one thing that we can do with the language server that's very specific to MLIR, this little thing. But because we're in MLIR, we can natively support the little split file marker thing. So the language server can treat all of our file splits as kind of unique programs in themselves. So I'll get processed separately. So that way you can have invalid code mixed with valid code, and all of the SSA values and other things get defined properly and resolved nicely. So looking at this kind of module, on the left-hand side is kind of an interesting view for me, because it shows the outline of symbol tables in the IR, which kind of maps to what you would expect from kind of like a C, C++, or any other modern language, where you kind of see the classes, functions, etc. You can kind of see it when I'm over here on the top part, which is what function I'm in, intermixed in all of this scoop. It's just nice for me because I can click through the functions that are, or all of the symbols in the module, and kind of find the one that I'm looking at. But moving on from that, if I'm moving too quickly, people can tell me to stop. But right, OK. What other ones? So there's also the thing that I mentioned earlier, which is the custom form of an operation. So if you hover, the zoom here is not helping me, but So for a function, I can actually see what the symbol name is, the type, etc. And I can kind of see that for all of the operations. I would note that the hover is probably not necessarily the thing that you like the most or the thing that you want to most see, but it was enough for me to get a feel of like, okay, that seems useful. So that's obviously something I can change and be tweaked if people want more information or etc. Hook into collapsible regions sections. I'm not sure what you mean, but
here, sorry, I can just explain.
I'm
you can get like an arrow on the side. I don't know what the right name for it is, but like you can then collapse the whole function and just see the function name. Like I don't know, I'm often working with like giant MLIR files where there are a bunch of like functions.
Yeah.
Oh, they just appeared.
Yep.
Wait. Okay. There we go. Perfect. Yes. The answer is yes.
Yes.
Okay. I think the arrows are always visible on my configuration. Awesome. That's fantastic.
Yeah. So I can't interpreting text is hard when I don't have sleep. Yes. What am I doing? Yeah. Right. Okay. So this file is simple, but it's not interesting, I would say, because I don't trust that I can write an interesting IR file in the span of like 5 minutes. So I wrote one beforehand. Actually, I didn't really write it. I copied it. So this larger thing is kind of the glob of a very simple PDL pattern because I had it offhand. But it's interesting to see because it's bigger than 5 lines. And it's something that we can kind of look at. You also see the nice outline view. I can click my function. So I guess one of the more important things is actually tracking references of things. So if I click on this function here and find all references of it, I can actually find inside of the matcher function where this is used, which is really nice for me because especially in PDL, nested references are kind of important because they happen a lot. But the same happens for any symbol reference can be tracked. And the same applies to SSA values here. So like %0 is kind of an example of what I was mentioning before when I was talking about why I have this, because it's defined like way up here, the very top of this function. But oftentimes this function is like several thousand lines long, and that's a lot of stuff to scroll through. But here, if I hover, I can kind of get a sense of what it is and the type. And if I really want to see where it is, I can always find its definition or find references of it. The zoom is weird. And the same thing for blocks as well. Just finding definitions of things. And then clicking through them. That hopefully gives a sense of majority of the features. I mean, they're not truly revolutionary from like a programming language perspective, but in terms of like interacting with an IR, they're kind of revolutionary for me, at least, because it's cut down a lot on my weird kind of trying to understand and like navigate the IR feel. I guess another one that's kind of interesting is if you have an operation that has an external location, like this thing right here, if you go to the definition of this operation, it actually takes you to the source file if it's within findable distance. So it's nice if you have an IR that's kind of formed from some input language, and you actually want to see where the operation came from the input language. But I think that covers the majority of the features, or at least the high-level ones. So I'm going to go back to the presentation now.
I noticed that the finding references is perhaps redundant with the like predecessor comments. Should those go away if we have like proper language server support? Those comments always kind of seemed like a
yeah,
I don't know, a little weird to me, but
I mean, it's useful if you're not in a language server, but if you have a language server, then it's like I don't need them. It's also interesting because if you handwrite the IR, the language server still works, but you don't have these.
Yeah.
So, I mean, it's redundant, but it's also like you're not guaranteed to be interpreting it from a language server, so I can see it.
But it could also be wrong, right? Like there's no, like it's just a I don't know. I mean, it's the same thing. Like we could have comments on every operation or every operand that comment where it's used and stuff too. But like, I don't know.
Yeah.
I mean, with predecessors, I'm not saying like every case is the same. It just those comments always seem to be like.
So the predecessor is coming from LLVM, I think, because LLVM is printing those. And when you work a lot with CFGs, which is not that common in MLIR, when you work a lot with CFGs, it's useful because like blocks are fairly linear, but then they can be in any order, and you want to find loops, and you want to understand your CFG. And if you use like print after all, for instance, when you are debugging, you're not in an editor or anything, and it makes it a bit easier to do that. But it's really something I think that was inherited from, it was done in LLVM, so when MLIR was developed, it was like, okay, let's match it.
Yeah.
Also, I think this is in the same category a little bit as the locations. So like, I don't know if you've ever used Godbolt. They have a way to just sort of be like, oh, well, turn off the assembly comments, turn off the, assembly source locations, all this stuff, because they kind of have a separate tracking mechanism. And so I think something could apply here where you're like, okay, well, just give me like the cleaned up thing. Like, don't give me any of these pred comments. Like, don't show me any of like the location crap. Like if I want the location, I'll right click and say like, show me the location or whatever.
I mean,
anyway, just an idea.
It's not possible until you start having actual tooling for stuff.
Yeah, the actual tooling is fantastic. This looks great.
Yeah, so that's the majority of the features, or at least the more interesting ones that I can demo, at least remember off the top of my head. So I guess I'll take a second to kind of introduce the high-level design, because it might be interesting in how a language server works, especially if you're interested in writing your own at some point. So if we kind of take a step back and think about what the server is doing itself, you kind of have two different sides here, and the MLIR LSP server is kind of smack dab in the middle of the two. So it kind of has to have some squiggly line communication between MLIR itself, which has the parser and your dialects and all of that interesting stuff, and the LSP client, which is your editor. It's going to have UI. So I'm going to start from the LSP side and kind of work our way up to MLIR somehow. So the first thing, if you're writing an LSP server, is you need to communicate with the client itself. And the communication in LSP is done through this JSON RPC. So you'll receive JSON RPC messages from the client, and then you'll send those back. So inside of MLIR LSP server, we have this dedicated layer, or this JSON transport, that takes care of unwrapping JSON messages and wrapping JSON messages. So this is pretty much the raw message handling layer that's going to do all of the raw communication. And for our server is a terminal pipe. So pretty much standard in, standard out is how it communicates with the client. So the nice thing about this is that our server is written completely in C++, only touching C++ APIs. And the LSP client, like VS Code, is written effectively, or you would communicate it effectively with TypeScript. So we don't actually have to do anything in the native LSP language. It's all in the language that we have the bindings for. So once we have the transport kind of sends any of these unwrapped JSON messages to this thing called LSP server. And I'm sorry, things are called LSP and server a lot, but that's just how it works when you're in a server. There's many servers. So this LSP server layer is kind of the handle. Have you ever written a communication client or some communication format? It's relatively and generally useful to have some layer that's dedicated to managing that goop so that it doesn't infect the stuff that we want to write specifically with MLIR. So that's kind of what LSP server serves, this layer inside of our main server infrastructure, which is just interpreting what messages come in from the client, and then sending responses back when necessary. So then it feeds into the MLIR part, which is this MLIR server part. So an important way to think about how the MLIR server differs from this LSP server is that the MLIR server is the only part of the ecosystem that communicates with MLIR itself. So our LSP layer, LSP server layer, sorry, doesn't actually know anything about MLIR, and it doesn't try to. It only understands things related to the LSP protocol. So if we want to take a quick example, you can think about if you're a user that types in something in your source code document. What will happen is a message will be sent across the JSON RPC that says, okay, for this file name, the user typed in like this bit of these characters. So that will get sent through the JSON RPC. Our LSP server will get it and see that, okay, something changed in this document. I don't know what changed. I'm not even going to try to understand what changed. I'm going to immediately pass it to the MLIR server to do any kind of parsing or verification. And it's going to give me some diagnostics in the LSP format. And then I'm just going to send that back to the client. So the MLIR server is the thing that does all of the communication and understanding with MLIR itself. So this is kind of the boundary between the two APIs. So the next bit is probably the most interesting realistically for MLIR, which is how does the MLIR server interact with MLIR? Because MLIR as a format in memory is not necessarily tailored to representing all of the details of the textual format. The textual format for us is just a developer tool, really. I mean, we don't have a bitcode format, but the textual format is something that's human readable, human processable. But the in-memory form doesn't keep track of all of that information, especially something that we want to expose via the IDE. So for example, the locations of operand uses. In any kind of high-level programming language, the use of what we would consider an operand or an SSA value, symbol, etc., is usually represented by like a reference expression, which has like a proper location. It has the name of the thing it's referencing, maybe some scope information. So in a high-level programming language, the AST usually has all of this information already encoded. This makes it easier to represent. Whereas for us, our in-memory representation doesn't really care about any of that stuff, so it generally just gets dropped. So we came up with this kind of assembly parser state thing, which is effectively all of the high-level textual information that we would want from the document that MLIR itself doesn't care about, doesn't want to retain, just wants to go away. This acts as kind of the bridge. So this ASM parser state collects all of that information so that tools can actually utilize that information for things like language servers or other kind of processing. So that's kind of a high-level overview of the different layers of how the server is implemented. I'm happy to go into more details if people have questions offline. But I think the most interesting thing is how do you use this thing? How do you use it for your own dialects? Because that's what MLIR is all about, right? So like any of our other tools, it's effectively written as the main is separated from the actual main. So in your main, you would define a tool that effectively just registers your dialect and then calls the real main. And then that binary can serve as your language server for your dialects in your project. So inside of Google, we have a web IDE, and we actually have effectively this binary, but with all of the dialects inside of Google registered. So in our web IDE, all of the users of MLIR can actually use or like interact with their dialects using the language server, and it's been working quite well. So I guess the status. So for the server itself, we support many of the core LSP features. So diagnostics, hover, cross-references, the navigation or outline as VS Code shows it. There's also a VS Code extension that's upstream, and that's what I was showing in the demo. The VS Code extension is not by itself interesting, but it provides, it pretty much sets up MLIR as a language, and it contains a setting for specifying what your MLIR language server binary is. So if you're in your own specific project, you can configure it to use the binary that has your dialects linked in. And that's kind of the only interesting part about it right now. But that kind of goes into future stuff, which is, of course, adding new LSP features if people find them really interesting or desire them. But also, there's a lot of interesting things we could do with the VS Code extension itself. Like, VS Code has this very interesting like notebooks thing. It's kind of like Python notebooks or Jupyter notebooks. And I actually prototyped this thing where you can run passes from inside of VS Code and then show which operations get generated and what they get generated from, which is kind of interesting. There's also opportunities to like auto-generate check lines or auto-generate verification lines because we have all of the information there. So it seems something easily doable where we could just auto-generate it for you. And of course, there's things like we could show the diagram of the control flow graph for the function that you're hovering over or the region. So once you start having the IR kind of there while you're processing a file, it makes a lot of these kind of interesting development tools much more easily accessible, especially if you only want to do that one thing. So I think we might try and do some GSOC projects that are kind of in the same vein now that we have something to kind of build off of. And yeah, that's pretty much everything I have in terms of slides.
So, yes, hi. So I have a quick question regarding the last future work item that you put. Yeah, so essentially this run passes. So what I find interesting is that I would say in the polyhedral community, and Alex Zinenko, I think, worked on this quite a lot at some point. But yeah, basically being able to visually transform your code and optimize subparts and stuff like that by clicking things and automatically, like as a user, kind of start specifying a set of transformations that would apply and see things happen incrementally and do that in an easy way sounds super appealing. So I guess I'm wondering whether you think this could be extended to essentially say, hey, you have your MLIR, whatever, at some higher level. And I would say clicky, apply whatever transformation in a quite local way. And essentially you kind of save the list of transformations that should be applied and save that into some script that can become a pattern rewrite at some point in PDL or something.
Right, yeah, so that's kind of what I've been playing around with outside of this, which is like running past pipelines from VS Code and then having it show kind of like a Jupyter notebook and where you can kind of click around to see how transformations lead into other transformations. And because it's like its own notebook format, it's actually saved as, you can save it as a file that is offline. And remember like what passes you used or pipelines you used to actually generate the IR that you were looking at that given time. So it sounds very similar to what you described, but I'm sure there's some slight things here and there that can.
I think there is one key difference is that in the work that Nicolas was referencing, the tools would allow you to click on a loop and say, tile this loop in particular, which is a bit different from saying run a pipeline on the entire module, because you get a handle to a very specific operation in the IR.
But that specific handle has always been the super painful thing, because essentially going in IR and inspecting and deciding, like writing the heuristic that decides how to get that handle is a huge part of writing heuristics, and it really sucks.
Yeah,
Halide,
sorry, go ahead.
Yeah, I was going to say Halide was somewhat revolutionary in that aspect, in the sense that it became a somewhat nice programming model to essentially keep your handles. Like you pass it handles, you receive handles. You say tile IJK, you receive MNP, whatever, and now you can do more stuff on MNP. Here, if you actually can see what you get and click it and essentially generate this sequence of things, essentially what I'm thinking about is like, all these patterns that we've been writing, like, yes, transformations as patterns become super easy to pinpoint and apply. Like essentially you say, hey, here's an op, you can say tile infuse with this thing, and suddenly, boom, you get your produced IR. You can benchmark it quickly on the fly, and then you can save the incremental step as, yes, I want that.
Yeah, so the granularity that I've been working at is things you can run passes on. But right. I mean, it depends on what's accessible from the server itself, because that's the things that we can generically call. But yeah, once you have, for like the server point of view, once you have the server, you can click anywhere in the file and know exactly what operation is under it, and actually have an operation for that to actually run passes on, or things like that. Joffrey, I think you have here.
Yeah, I was wondering, so right now it sounds like you get to pick one server binary, and that's the one you want to use for like, everywhere you are in VS Code. I frequently work across projects, and so like I have a binary that works with Erie dialects, and it also works with core dialects, but then there's a different binary that also works with the TensorFlow stuff. Do you see any way to like allow you to dynamically register dialects, or figure out, I mean, like from the file content, you should be able to figure out what the dialects are, and so like you could, I don't have an idea of how this would work really, but it would be nice to not have to have one binary, but instead, like obviously you have to in some way register your stuff, because you can't have the extension have to know about everything, but like have some way of dynamically being like, oh, this is a TensorFlow file.
So I don't know if it is easy to do dynamic, but what I've kind of been relying on is that you can change settings for VS Code per workspace. So conceptually, you could have like your different workspaces use different binaries, and I think that would just work depending on how it's siloed.
I think you would literally just create like a new VS Code window within like an empty directory with a .VS Code file that configures like pointing at the TF language server.
Yeah,
and you just open up that one.
Yeah, no, there's definitely, I mean, there are definitely ways to like have another workspace. I was wondering if there's like any way for it to, because I know like usually it works on like file extension or something, any way for it to introspect the file and be like, oh, I see TF dot whatever, or I see Erie dot whatever. And previously you've told me that that requires this binary. I don't know. This seems like a less useful feature than like all this great stuff here. Like if I have to change workspace, it's not the end of the world.
There are definitely ways that, I mean, yeah, for me, it's like, how would we detect it, and would it be easy / reasonable? Because I mean, there are different things that we could do from the VS Code point of view. This is just the easiest thing that it's like, this covers all of my cases that I have right now.
Yeah, I think it's interesting because, one of the great strengths of MLIR is its extensibility. And so like people being able to, I mean, like even another thing is that it would be nice if people didn't have to actually like create their own binary. Like if they could, if they could provide something that then it hooked into. I don't know. This is definitely like getting way more complicated.
MLIR package manager.
I didn't say it. Shad said it.
Actually, I think Stella did it first.
Okay.
Just wanted to point out real quick on the language stuff, you can set per file language overrides, and those are stored in your workspace. So if this was something that the language server was picking up based on the language mode of the file, you can override that. So not fully automated, dynamic detection stuff, but you would at least be able to do it within a single workspace.
So you could pick a file and say like, no, for this file, we'll call it MLIR-TF and use this other server binary.
Yep, and there's like a control P change language mode that you can use to do it.
That seems pretty reasonable.
Yeah, I mean, I don't know how that interacts, because a lot of times you register it for a specific language and like the configuration for the extension. So I don't know if it would get very angry with, I don't recognize this language, unless language mode is like a sub-language mode or something.
Oh, right, you only have one instance of the extension, yeah? I don't know if you can have register the extension multiple times for multiple languages and create pseudo languages that are like MLIR dialects.
Yeah, I would have to look into how VS Code handles it, because some of the stuff gets a little weird with a lot of the language support.
Yeah.
River, I have a question related to sort of the workflow here. So what's sort of the expected workflow with this, binary that I built for my project? So like in particular, I'm thinking about the use case of like, I'm hacking away, I'm adding new ops and stuff. And so in general, I think that will require rebuilding the language server. And so do you recommend just sort of pointing at the language server in your build directory and sort of hope that, VS Code kind of refreshes it frequently enough, or like just stash one away and manually refresh it?
Yeah, so what I've been doing is having it in my build directory, because at least, yeah, the specific case that you mentioned, which is like I'm adding a new op, and now it's the language server is immediately like, well, this op, I don't know this, this thing is unregistered. What is this? So that's what the way that I've been approaching it is that if I'm actively adding new ops and I want to keep the thing up to date, then I need to have a fresh build of it. But I mean, I don't have. Ben, you were going to say something?
How do you trigger that? Do you hopefully not close Visual Studio and then reopen it when you change the binary or whatever? Like, is there a relaunch language server so that my build system can actually overwrite the executable kind of thing, or?
So I need to check to see exactly what VS Code does, because VS Code does have a lot of support for relaunching the server itself. One thing I'm not sure about is the fact that sometimes it's like, I don't know if it checks it like, oh, the server binary changed, let me relaunch that for you. So that's something that if it's not doing it automatically, that's something that we could detect automatically. I think.
Have a watchdog or something that's just
and then changes. Like, okay, let's kill it and then relaunch the extension with the new, or relaunch the server with a new one. But it's like this is a lot of integration stuff that, like, because it's been mostly like out offline, that will be, I'm hoping will be kind of like figured out as we start using it. People start using it more, and it's like,
oh okay, yeah, I'm gonna set this up ASAP. This is awesome. By the way, do you have like install instruction? I mean, you kind of given the overview here. Is it just the extension plus LSP config setting?
Yeah, it's effectively what it is. So on the website, there's a doc for it. So the VS Code extension is hosted on the mono repo, but what we want to do is set up like a proper GitHub repo for the extension that has pretty much everything set up to build. But that doesn't exist yet. But there should be installation instructions on the website /tools/VS Code or LSP server or something, MLIR LSP.
And will you be putting this in the market, whatever it is?
Yeah, I think that's the intention.
Awesome, because there is a MLIR thing in there that adds highlighting. It would be nice, but it only supports some specific dialects and all those things. So is this going to like ideally replace that?
Yes. So awesome. It has syntax highlighting that we have in the mono repo for MLIR. It'll definitely be more interesting now that we have a proper language extension that we could add potentially semantic highlighting, which could be really interesting. So yeah, this is intended to replace any other .mlir extension that you have, because it's based on language mode, and VS Code doesn't like it if you have multiple things on the same language effectively.
Can you show the link or paste the link in the chat for the sort of current installation instructions?
I just did.
Okay, great.
It'll go away as soon as the chat ends, but
yeah.
Yeah, this is awesome, River. Super exciting.
Yeah, hopefully people find it useful, or at least if it's not immediately useful, we can turn it into something useful. But I would at least found it interesting to use so far.
Yeah, no, I was doing debugging like last week where this would have been very useful. I was doing exactly the same type of thing where I was like, where the hell is this defined? 500 lines up, I guess.
Yeah.
This looks awesome.
All right. Should we leave it there then? If we don't have any more questions.
Awesome.
Yes.
Really looking forward to use this.
Yep, me too. Thanks, River, for the talk and for the awesome walk as usual. Thanks everyone for joining. Next week, we're going to have a presentation on DECL, a declarative and dynamic way of extending, creating new dialects, operation types and attributes without writing C++. That's going to be interesting as well. All right, see you next week. Bye, everyone.